Welcome, ma'am. Topic for discussion is continuous data in normal distribution. So, morning session we just a recap of continuous data. The hypothesis for two groups for the above data. Criteria for the student t-test. Describe them. This is just a recap. We have two types of data, number of values between divisions. So discrete data is again divided into categorical and integer. For all practical purpose, we will consider the integer data as continuous data now. So this is the data of 25 subjects weight. Now we have in a frequency distribution, we got this type of. If we distribute, it will get a normal distribution. In a normal distributed curve, the mean, median and mode will be the same. The same if we have this type of data, which there is no central tendency. This is called non-normal distribution curve. The median value depending upon the mean, it is said as right skewed or left skewed. So in a normal distribution curve, the mean gives the measure and the standard deviation gives the dispersion of individual data. Whereas in non-normal distribution, the median gives the measure and the percentile quartiles and interquartile ranges will give the dispersion of the individual data. So now we are going to test the parametric t-test. So the predictor is the categorical one and the outcome is the dependent variable, which is always continuous. And for one group, it is going to test by z distance, and we will come to know it in later slides. And in two different groups, it is unpaid student t-test, and in the same group with repeated measurements, it is the paid student t-test. So what are the criteria for student t-test? So first, the data should be continuous and it should have a normal distribution and the variance should be equal. If the variance is unequal, then we will follow the Welch's test. So here we are dealing with two different samples. For unpaid different subjects like weight of the students in section A and B, or the post-op analysis duration of group drug A and drug B in 30 patients in each group. And for paid, we have repeated measurements like blood pressure measurement before and after a drug administration, or weight of students in section A and B after a nutritional program. So this is the two groups we are having the data. We have calculated the mean. Then we have calculated the sum of square deviations from this variance, and the standard deviation is calculated. For unpaid student t-test, we got two means, two standard deviations. The group 1 mean is 70 and the group 2 mean is 50. So whether this 70 minus 50 difference is 20 minutes, whether it is significant or not, we have to test. So according to null hypothesis, it says that both means are equal and there is no difference. Both groups are from same population. Whatever difference has occurred, it has occurred only by chance. Whereas in alternate hypothesis, it says that both means are different and they are from different population and the difference has not occurred by chance. There is a real difference. So suppose if the difference of mean is 20 and the standard error for that difference of mean is 7, and you have to calculate a critical value, that is t value, which is given by the difference of means to the standard error of that difference of means, that is 20 by 7. If the value is above 2, the difference is real and significant, and it says the probability to occur by chance is less than 0.05%. So we are going to reject the null hypothesis, which is favoring the alternate hypothesis. So if the difference of mean is 20 but the standard error is 11, so again the t value is calculated. If it is below 2, the difference has occurred only by chance and the probability to occur by chance is more than 0.5. So we are unable to reject the null hypothesis here. So this is the same thing explained in graphical representation. So whether the two standard deviations in the include 0 or not. If it is including 0, the value is near to the mean. So we can't reject the null hypothesis. So probability of the difference between means to occur by chance is more than 0.5. So that is null hypothesis is accepted. The same thing opposite is alternative hypothesis. So paid student t-test. This is applied when in the same group with repeated measurements like weight gain in students in a section after a nutritional program. So here actually we will calculate like this. We will get a mean and the sum of square deviations, variance and standard deviations. But in same group we have weight before and after and calculate the difference, and the difference you have to subtract the mean from it and you will get the sum of square deviations, then calculate the variance and standard deviation and the standard error. Then you have to calculate the t value, which is given by the difference of means to the standard error. That is 2 divided by standard error is 0.5, so which is 4, which is about 2. So the p value here is less than 0.05, where we will reject the null hypothesis and favor the alternate hypothesis. So the difference has not occurred by chance. It says that the nutritional program is effective in increasing the weight of the students. So in a single group, it is the z value. So what is this z value is the distance of value from the mean. Suppose we have calculated, here is a study, we have calculated a population mean for example thyromental distance, which the mean has came to 6.5 centimeters and the standard deviation is around 1 centimeter. They got a mean of 6.8 centimeters. So this z value helps in this study. So how to calculate this z value? The calculated mean minus the true mean divided by the standard deviation, it will give the z value. With that you calculate the standard error and t value. So difference of mean is 0.5 and the standard error is 0.2, which will get the value of, in Pondicherry study is 2.5 and the Bangalore study is 1.5, which is less than, Bangalore study t value is less than 2, so it will favor, the population is similar to the generalized population, whereas in Pondicherry study the population is different from the general population. So this, how to understand the p value. So the two standard deviations around the mean, obviously it will include 95% of the confidence interval, but this value is not constant in all the subjects, all the sample sizes. As it varies, this value will also vary slightly. If it is increasing, the value will slightly decrease. If the sample size is decreased, the value will slightly increase. So these are the values we will get for 95% confidence interval in different sample sizes. The same thing if we get will get 99% confidence interval and 90% confidence intervals. So this is the critical value table for two-tailed. Two-tailed means if the change is expected in two directions, either in positive or negative direction, it is called two-tailed. And these are the critical value t value table for different number of subjects. And this is critical value table for different group number of sample sizes in one tail, where the change is expected in unidirection. And this is for combined both two-tailed and one-tailed critical value table. So what is the degree of freedom? It is the number of independent data for a given group. It is always denoted as n minus 1. For more than one groups, it is n1 minus 1 plus n2 minus 1 and so on. So standard error calculation is given by the formula standard deviation divided by root of n minus 1 for one group. For difference of means, this is the standard error calculation formula. Thank you.